So one more thing, real quick, I forgot to mention as well. I forgot to kind of go into detail about why I think this is such a cool method for rendering terrain, for defining terrain. I mean, if you're familiar with this, then you already know. But I kind of want to go into a little bit of detail. I think it's really, really fun, really cool how this kind of approach allows you to create games that have terrain that is modifiable. Again, I'm going to mention Astroneer and the new Donkey Kong game because these, you can see in any gameplay footage, is very clear. It's all the terrain is destructible. You can create new terrain. You can modify you can do so many things. I think it's so interesting and so much fun. So it seems like there's so much potential for different genres of games to take advantage of this. I think it's really interesting. In addition to that, there's also procedural terrain generation, which I believe Astroneer does. I don't know about the Donkey Kong game, but this is another aspect of this that I think is so interesting and exciting. Being able to create an algorithm, a custom algorithm that you can, modify and tweak to try to create really, really cool procedurally generated terrain with different parameters, all of this stuff. So what I'd like to do as well, once I've gotten a bit further along with this project, I want to create separate modules that properly, what's the word? I guess organize this algorithm, the different parts of this code, into, I guess for the most part, two separate modules, right? One would be for generation. It's not even really terrain generation. It's scalar field generation. And this would be the initial part, which you really just pass in as parameters different values. I'm not even sure what these values would be called. I haven't looked in too much into procedural terrain generation yet. I'm very interested to see kind of what techniques exist for this, but it's really just for generating the scalar field, just for generating the numbers, right? And the other thing is you don't, what's also interesting about that is you don't need to immediately generate an entire, or you don't, it's more functional rather than data driven, if that makes sense. So it's not like you're creating a function that saves a giant collection of numbers and then you just reuse that giant collection of numbers. I think it's really more like you provide a seed for the randomness, right, for the random number generation, and then anytime you provide that seed to the function with the same parameters, then you get the same value for each point in space. And so you don't even need to really save any of these values. It's always just going to be possible to generate these values again. So that's what I think is very interesting about the scalar field generation side, the procedural generation side. But then also I want to have separate out this logic so that in the other module, that one would be entirely focused on taking the scalar field as input and then rendering the 3D mesh, the surface and everything as the output essentially. And so these would be two separate functions or two separate modules. I think that, to me, that is it's very fun to think about this, the way that this is going to be organized. What else was I going to say about that? Shaders. I've been thinking about shaders a lot as well, and to be honest, I don't have any experience with shaders other than seeing a few videos about this. But that's another obvious thing that I'm going to want to look into regarding this, because really, when you think about it, rendering this is half of the equation, and having, say, you want to have destructible terrain or modifiable terrain, and you want to have physics and things like that, you at least want things to be able to interact with the terrain in some way, right? And so the interacting side of the terrain is all going to be handled, CPU side, if that makes sense. So this is all handled within the game engine, within the code of the game. And that actually works out fine because collision detection is only necessary for objects that are near something that is potentially solid, right? So when it comes to that side of the logic, you can imagine the entire surface of the terrain can basically be ignored unless you have an object nearby. So for example, if you want to roll a ball down a hill, the ball only needs to understand what the surface directly beneath it looks like, right? Or what the shape of that surface is. It doesn't care about any of the terrain surrounding it. So on that side of things, this is where the functional side makes a lot of sense, because it can just very quickly generate the values that are nearby that object, and you don't have to worry about anything else outside of the range of that object. But then on the rendering side, it's obviously much different. You need to render everything that's visible, anything you want to see on the screen. So I believe this is where the shaders make a lot of sense. This rather than being CPU side, it would be GPU side. The graphics processor would handle rendering all of these triangles, and hopefully it can be done. I mean, of course, it can be done in parallel. So that would make, because I think this is another issue with maybe a reason why this algorithm is not used, or traditionally has not been very utilized in the past, because computers and game consoles in the past maybe just didn't have the processing power required to do this. But nowadays we do. And I mean, even this, I'm doing all of this on CPU, right? And then generating the mesh and everything on CPU, and then it's just rendering using whatever Bevy. I'm sure Bevy uses, it has its own way of rendering using the GPU. But if you can utilize the GPU more extensively, then it takes away so much of the load, the processing load from the CPU, that really the CPU can just worry about the physics and everything, and the GPU can handle figuring out where all of this terrain should be rendered. And it can do that in parallel. So where right now, the term marching cubes, it's literally marching through an entire long collection of cubes or cells in a 3D space, one at a time, right? And that's incredibly inefficient. So we want to do this in parallel, trying to render everything at the same time using the power of the GPU. So that is the ultimate goal. That's another reason why I'm so excited about this. And I mean, I'm thinking about this all the time when I'm, out for a walk or taking a shower or whatever. I've been thinking about this so much. And so I'm very excited to see how far I can take this.